In this example, once more, we're going to be making use of the definition of continuity to determine the following. We're going to determine the value of c that will make the function f continuous for all real numbers in its domain. The function is f of x is equal to c x squared plus 2x for all x less than 2, and x cubed minus cx for all x being greater than or equal to 2. Now, these two rules that we have for our function are both going to be continuous on their respective domains due to the fact that we have a quadratic and a cubic polynomial function for each of those rules. Therefore, in order for this thing to be continuous on its entire domain, we simply need to check continuity at x equals 2. That is the point where the rule changes from one to the other. Now we already have that the function is defined at x equals 2. We simply need to check the left-hand limit and the right-hand limit. So for the left-hand limit, we're going to consider the limit as x approaches 2 from the left of f of x. And we're also going to consider the limit as x approaches 2 from the right for f of x. Do keep in mind that the left-hand limit means that we're talking about only values of x that are less than 2, which is why we're going to go with the top definition of the function. So limit as x approaches 2 from the left of cx squared plus 2x. Now because this is simply a polynomial function, we can apply the direct substitution property and say that this will be c times 2 squared plus 2 times 2. Giving us the expression 4c plus 4. Now that's as far as we can take it for now, but we are going to compare it to the right-hand limit. For the right-hand limit, we're considering values of x that are simply greater than 2, which is why we're going to be using the bottom rule for this. So this will be the limit as x approaches 2 from the right of x cubed minus cx. That was our bottom rule. Once again, we can apply the direct substitution property and refer to this as 2 cubed minus c times 2. Now, we simplify this expression as much as possible, and we get 8 minus 2c. In order for us to actually achieve continuity, we need that this limit exists, and the only way that the limit can exist is if the left-hand limit is equal to the right-hand limit. So we set these two limits equal to each other, and we are now going to solve for c. Solving for c, I'm going to add 2c to both sides and subtract 4 from each side. On the left-hand side, that gives us 6c, and that's going to be equal to 4. Dividing both sides by 6 and reducing the resulting fraction, we get that c is equal to 2/3. Now this answers the original question posed, which was determine the value of c. Well, we have officially determined the value of c. If you wanted to check your answer, feel free to go back to the original function and plug in c equals 2/3 and then try these limits once more.